Our next speaker is Konrad Gawda. He is a network specialist working for R&D of one of the biggest Polish telecom operators. He is also a member of PyWaw community since its beginning. Over the years, Konrad gave 6 talks there. He will tell us about software-defined networking in Python. Please welcome Konrad Gawda.
Hello everybody, and yes, that's right. I will be speaking about software-defined networking, or SDN. And I will try to talk about 3 things. First, about the SDN concept, then about the OpenFlow protocol, and then about the software that can use it. So in the end, I would like to leave you with 3 conclusions. That SDN allows to control network by a software, by an application that we call controller. The conclusion that OpenFlow is one of the protocols that allows this, and that POX and Ryu are some of the Python's frameworks for writing such controllers. But let's start from the beginning, because we are talking about network. So network classically, in the network, in the internet, you have routers and switches. And those are, in the classical view, they are really magnificent things, like in a Gothic architecture. When you have routers, they have implemented the routing protocols, like BGP. It's really a masterpiece. Each router can talk to other routers to build some common knowledge in a distributed way. So that's really a masterpiece. However, it's not very flexible. On the other hand, you have switches, like Ethernet switches, which are very simple or quite simple devices and quite cheap, but with a very limited functionality. So this was great, but then the world is changing. People are looking for better solutions, and also there are new needs. And data centers with virtual machines which appear here and there, and then they're all migrated, teleported. This needs flexibility, and this needs new solutions. Software-defined networking, in fact, its a core idea is to detach control plane from data plane. So that's about detaching the fast forwarding of the packets from the thinking, from the finding that what's the direction, in which direction which packet should be forwarded. And that concept of software-defined networking is not a new thing. Scientists and engineers tackled it at least in the 90s. And there were many approaches, among which we can see approaches which tried to use completely new hardware, like you must develop new routers, or on the other hand, approaches to utilize the hardware just like it is right now. For example, abusing in somehow BGP protocol to control those routers from an application. Well, in 2008, OpenFlow appeared, and this one gained popularity. So I will focus on this one, even though that in similar time and later on, other new protocols appear to handle this task. But I will focus on OpenFlow as it's quite popular. And OpenFlow, yeah, it's open, so it's a standard that is commonly known, and it's standardized by Open Networking Foundation. If you would like to see the document, go to their page, and on the right menu, click Technical Library. That's the place. Before going forward and talking about how this protocol works, how OpenFlow protocol works, let's think for a moment how a router works. Imagine you want to build your own router. Come on, it's a great business. Those devices are really, really expensive. You can earn a lot of money on this. So take some PC, with Ethernet cards, and come on, it should work. Yeah, okay, that will work, but for those really expensive devices, you need performance. So you will need some dedicated hardware, dedicated circuit, integrated circuit for fast forwarding the data. And though you still need the processor, like in a PC, to compute the knowledge, to build a knowledge where to put which packet, for example, to understand the routing protocols. And so, in fact, that's how the devices are built classically. So, in the top, there is some CPU, some processor, that is, for example, handling the routing protocols and other control stuff. But in the lower part, there is an accelerator or a network processor that forwards the packets, and if there is some special packet, like control packet or something that it's unknown, doesn't know what to do, it handles to the CPU. And in fact, this is a place where OpenFlow hits. And OpenFlow is just an idea to standardize this interface between the forwarding part and control part. So the idea is to have an application that will be able to talk with quite simple devices, and we will call them OpenFlow switches, even though they can work as routers, as switches, and as many different things. So to standardize a protocol which can say to the forwarding device, to the switch, for packets of such and such types, do such and such action. And as you can see, of course, if we have such application, one such controller can control many different switches. So here is a core of this idea. So in the top, we have this application, the controller, and in the bottom part, you have what is inside of this forwarding hardware. There is a table. There is match and action part. So it says that if a MAC address of a packet starts with this one, forward it to port 1. If IP destination address is something, forward it to port 2. For packets which have TCP port 25, drop, and so on and so on. And that's basically the level on which OpenFlow operates. So it's match and action. And this match is not only on the Ethernet layer, not only on the IP layer, but also on the TCP and UDP layer. And that's how far the OpenFlow go. It doesn't go to HTTP. Okay, so we know what we're working with, what the protocol is really handling. And so what the protocol can say. There are some messages, but those 4 are the most important, and it's asynchronous. So the switch mainly says, hello, I'm connected to you, Mr. Controller. And in some other occasion, it says, hello, I've got such packet, and I don't know what to do with it. And the controller is able to say, save a rule for packets, so if there is some match, like this and this, do some action. And the other thing that the controller is able to say is, send a packet. You've got a packet like this, and please forward it to some port of yours. So, in fact, what you can see that we could even abuse it, this whole framework, to make just a software proxy or process all the traffic in the software if we would like. For example, we don't learn the switch anything. We don't teach the switch anything. So each time a packet arrives, switch doesn't know what to do, so it sends it to the controller. The controller does some modification or inspection of the packet and sends it back to the controller. But that's not the main idea how to use it. The main idea is that a packet comes, it's forwarded to the controller, and the controller says, okay, that's the destination IP address, and from my lookup table, from my knowledge about the network, I say this link is okay, and perhaps also encapsulate it in some VLAN. And this switch writes a rule to the controller, this controller writes a rule to the switch, and it also says, please do it for the packet that you just sent me. So, to recap on this part, you have a network of devices, of SDN switches or OpenFlow switches that can be managed by the application. Is it one single application, or are there several ones? That can be done in different ways, but there is some layer of the controller, of SDN controller. And then if we go further, we can think about, okay, let's don't keep it a closed application. Let's put some API to make working on the services simpler thing. So, for example, I have some controller network, some controller framework, like we have Django, and then in Django you can have your logic divided into several applications, Django applications. So that's similar idea here, to implement different networking services in a different applications that will be run by a controller. And while we are talking about it, it's some very, very perhaps new thing, but in fact, this is something that is already happening, and over the last few years, vendors have proposed many different physical devices that are able to handle it. So if we say SDN switch, there are really such things. And even though there are physical ones, the software implementation is also very important, and for example, Open vSwitch, part of Linux, is able to be controlled by OpenFlow, and this is also very heavily used, for example, in data centers. Okay, so that was the introduction. I hope you feel a bit how the OpenFlow works. Perhaps you wonder why it's useful. So one use case is about the data centers and dynamic connections between virtual machines, but for network operators, it may be also useful. But let's see it in action. Let's see it in action, and you can do it, and what you really want to start quickly is a virtual machine when you have everything set up, and Mininet. Mininet is a tool that's useful for this. Let me just ask you, how many of you have heard about Mininet tool? Okay, there was some movement. I've seen some people. Okay, so what I've done, I've downloaded Mininet virtual machine. That's no change, and I have running it on my laptop. Now I have logged into it. And well, what we have here is the Mininet application. So basically, it's you call it MN, that's Mininet, but I will also tell it to start it with 3 machines, with 3 devices. So this will be a topology like this one, with some kind of switch, OpenFlow switch, and 3 hosts connected to it. And then we'll start controller. So now you can, perhaps you have seen that I deleted the line saying controller external. So now the Mininet tool is using internal controller. So I can ask host 1 to ping host 2, and yeah, it goes. So nothing really surprising here. That just shows you that we have this setup here and it's running. So yeah, that's not really the most interesting part. The most interesting part is, let's call it with remote controller. And just guess what will happen. The host is unreachable because the OpenFlow switch is looking for a controller. There is no controller. Okay, so let's give him one. So I'll open another console. And I will start a controller. And this will be This will be POX controller. Before starting it, let me just show you what is the API of this magnificent thing, which is POX. So POX is a part of a bigger project, Nox. Nox was written in C, and POX is written in Python. It only supports OpenFlow version 1, so it's not really carrier grade, and it's not developed for some longer time. However, it's very useful for simple things. So what I'll do, I will start the controller. This is just some part that asks him to make a pretty log. And in fact, the real task is here. The real task is here, and I will change it. I will ask him to work as a hub, forwarding.hub. Okay, that's started. The traffic is now forwarded. If you're into the networking things, hub is the simplest possible device. It just floods the traffic on all the available ports. So it's not really a great deal. Let's see how it's implemented. So this is the code that POX uses, and in fact, yeah, that's all of it. That's all of it for the hub. So it does two things. It adds listener to listen for OpenFlow connections from the switch. The switch will say, oh, hello, I'm connected. And then, when the switch is connected, another OpenFlow message is sent, this time from the controller to the switch, with an action saying, output the packet, flood, so on all ports except the input port. And see, there is no match here. I said before there is a match and action. So there is no match, so this will be done for all the traffic that is sent to controller, to the switch. So that's not really amusing part. I mean, you can see the log, and you can expect there will be saying hubifying something, and yeah, it really says, and it will do it once for a switch. So that's a simple thing. Let's go for something more interesting. So I will start again the mininet. And as I stop the controller, there is no communication. And this time, I'll run the same line of the controller, but I will say it forwarding.l2 learning. L2 learning, so this is MAC address learning. So in this concept, that's basically how the normal office switch or the switch that you have on your desk works. So it learns the traffic, where it comes from. It receives a packet and sees, oh, that's a packet from computer A, so computer A is there, so all the packets for computer A should go this way. And it remembers all the computers that talked to him. So, okay, let's launch it. Okay, we see the traffic going, and we also see 1, 2, 3, 4. We see several printouts because several computers out of those 3 send packets. So I will stop this ping, and I will. Now I ask computer number 3 to ping computer number 2, and what you see, it's another messages, because this time the switch acts each time it receives a packet from a new unknown source. Okay, let's dig into the code. This time it's a bit longer, but there are also some basic things that are used and much of the code for some corner cases. So it says on connection app, so if there is switch connected, if there is connection app, build a new object, learning switch, and then the whole fun will be with this object. So that's the init of this object. And here you can also see add listener. So this very object will be also having a listener for a packet in. So it's the same story. So that's the story. And I said, there is a packet and I don't know what to do. Then the controller says, okay, write some rule with some match and action. So this will happen here. So there are first important thing is here. So here we just write down to learn. This is the learning part, to learn that computer A was from this direction. So we remember MAC address and port. And then there is some multicast handling and so on, not really important. And this is really important. So we'll be writing the rule. The match will be here, and you can see it's from packet. So build a whole matching rule that is take all the fields from the packet and make an action, and the action is forwarded to port, and the port that's taken from the dictionary that we wrote to a moment before. And in fact, so this is an example from POX, and in fact this example is very simplistic, meaning that it's taking all the things from this packet. So it's not only taking MAC address, because you don't see saying take only MAC address or take only IP address. So in fact, it takes all the things that POX can parse and writes it to the rule. But it's simple and it works. So to go forward quickly, I will just say you that POX is one of the frameworks for writing such applications. Another one, more recent, is Ryu, and that handles OpenFlow up to 1.4, as well as netconf. And here is some example code. It's here just to show you that it's a quite similar approach. I mean, you make some listener, you get the callback, and in an answer you write some packet with a match and action. So that's Ryu. And the third one, because I want to show you three controllers, or three frameworks for controller, is Pyretic. And this one is not very popular, but quite different from the others. It's mainly from the academic background, but you can see it has completely different idea of view. It works more about the filters and building a tree of filters. So the top two lines show some composed filter, and the bottom two lines show a filter which is a match and action. So if the IP address match, forward it to port number 1. If the IP address does not match, forward to IP port number 2. So this is also some way of more high-level handling of OpenFlow, and that's also possible. So I would like to conclude this part and to say that what I said in the beginning, software-defined networking allows us to control network from the application, and the application is called SDN controller. OpenFlow is one of the protocols that can be used for this, and POX, Ryu, as well as Pyretic, are some of the Python frameworks how to make those controllers. Well, and that's the main thing that I wanted to tell you, and please let me know if you have any questions.
I have a question. Where is this code executed, the Python code? Is it executed on the router or on external server? isn't a performance hit because of external server that has to be consulted for each packet passing the router?
Okay, the code, the Python code, or the whole controller code is executed at the controller. So it's some kind of server. And this, so the router, you don't have to change anything in the software, in the firmware. No. You take the router, perhaps configure some basic stuff like IP address of the controller, and that's it. All the control, or all the logic is done by the controller. Is it a latency issue? Well, if you design it correctly, it shouldn't be. First of all, you should support some good connection between them. But on the other hand, if we work like the examples before, you have the communication between switch and the controller only when a new flow starts. So for example, I want to, as a user, as an end user, I'm sitting somewhere here and I would like to download a file from there. So a new TCP session starts and the first packet comes to OpenFlow switch. It asks the controller answers. The packet now is transported further. So that's additional delay, but it's only introduced in the first packet.
I have a question. What happens when you want to move some virtual machine with its say IP address to another location and route this packets via another port?
Okay. So basically, if you are in the topic of virtual machines, maybe I will just mention OpenStack, because OpenStack is also Python, so we love OpenStack, at least some of us. So OpenStack has a special part, the neutron part for the networking, and this part has plugins. One of the types of the plugin is ML2, modular layer 2, and this one has a plugin called Networking OF Agent, that's OpenFlow agent, and this one is using RU. So in fact, when we are talking about RU, we are already somewhere in the scope of OpenStack. OpenStack can also handle OpenFlow in a different ways. That's quite complex topic. So that's basically OpenStack can handle this, can use OpenFlow, and how it's done. Well, OpenFlow gives the possibilities. OpenFlow gives the possibilities of match and action. So if some packet, for example, we could make it this way: new packet arrives at the data center from the outside world. So check what's the destination IP address, and basing on this, forward it to a proper port. Or if you have more switches, perhaps encapsulate it in a VLAN that will go to a proper machine. And you can also, so forward is to a specific port is an action, encapsulate it in a VLAN as an action, but you could also make some rewrite in the packet, and that's also some action that OpenFlow can handle. So you could change the destination IP address, and you could also change the MAC address, or just write some MAC address in this Ethernet packet, and you could even change the port in TCP. So the switch will recalculate all the checksums.
Thanks for the great talk. I'm here. I have actually two questions. One question is about is there a killer app, meaning there are hundreds of protocols, network protocols, OSPF, VLANs, BGP, probably you know much more than I do about it. So what problems OpenFlow can solve for me that all the other protocols could not? That's one question. And the second question is you told that the switches are the dumb part and controllers are the smarties. So what happens if controller is down, or how do you prepare for this, for availability of this controller?
Okay, so first part, why software-defined networking? In fact, we people, we are curious. If we, at least we engineers, if we see something, we wonder, could it be done better? I see some technological solution, and perhaps I see that it's not very elegant, perhaps it could be done in a different way. And that's maybe some academical approach, but I've shown you a picture about different protocols that were tackled in the 90s and so on. So the engineers and scientists were saying that it could be perhaps done in some better, more flexible and smarter way. But in fact, there was no real progress, and yeah, people were asking, what is the killer application for SDN? Because no one will introduce it without one. And some people said that testing will be great because telco operator will be able to test their network setup. In programming, we can do testing just like that, but imagine all the switches. Even if you make emulator of the switch, it's not the same as a real router. Some others said that business services will be great because you can provision some combinations of VLANs and specific connections for business customer just like that. That's also not that catchy. And then the virtual machines in data center appeared, and that seems to be catchy enough to talk about this. So why it's better from, for example, VLANs? With VLANs, you have limited number of VLANs, and then you're done. I mean, there are ways to cope with that, but it is somehow limiting. Then there are other protocols, and they have like some functions, some ways to cope around. OpenFlow or SDN in general is aimed to give much more, because here you don't have the pre-programmed logic in the device, in the switch or router, which has the limited amount of functions, and you just turn on the function. You can write your own logic here. So, and this logic can work together with some other APIs of your system. So I don't know if that's really answers the question, but yes, it gives much bigger opportunities in this way that the owner, the operator, defines what the networking devices do, and if there are some other protocols that allow this, they are in the same family. And what was the second part of the question?
About high availability of the controller. So what happens if the dumb part cannot communicate because the controller is down or something?
Yeah. Especially as a telco operator, you're really concerned about this. And perhaps that's one of the points why you don't really see it everywhere in the telco now. That's a really, really important thing, and for sure you must have a good network for managing the networking devices. For sure you have to have several instances, and there are some solutions for managing several instances so that they work together. That's not the case, at least I don't know, for the POX controller. And for example, for the smaller scale, for the OpenStack, I'm not completely sure how OpenStack handles this, but I hope they found some way to manage this in a smart way.
Okay, I've got a question. Here. Okay.
Hi. Could you tell me if these frameworks have built-in security features that can, for example, distributed denial of service?
Okay, so this question has two hands. Like one is that can it be attacked? The OpenFlow interface, can it be attacked somehow? And yes, it's a very vulnerable interface. It's a management interface. So if someone has access to it from outside, that's a bad thing. And even though maybe it should be more secured. And that's a really open thing. Perhaps there are some solutions yet for this. And the other way of this question that could be understood is, can OpenFlow and software-defined networking be used to improve end-user security? And that's the easier question, because yes, it can be done, and there are many ideas how to make it. For example, the switches could take the DNS requests and forward it to some other server, or even the controller could process it by himself. Also, for such things as, for example, parental control, this could be used for dynamic denial of service. I guess also a service could be used to protect customers against it, or our virtual machines against it, but I don't know the exact solution. So the security of OpenFlow protocol itself, yeah, it's a very important topic, and security services you could build on it, it's a really nice and open topic.
Okay, so what are the possibilities of this to find adoption in our homes? Like this parental control, but everything else?
Yeah, in our homes. In fact, first of all, in our homes, because most of us are programmers, so we are playing with virtual machines and so on. So perhaps it's quite soon, or perhaps some of you already use it somehow, because Open vSwitch in Linux is commonly used for connecting many virtual machines, and that you can use OpenFlow. So in this way, for developers, for sure, it's great fun. For the services from the telco operator, perhaps yes, and perhaps it will be used, but rather in the network. So not really in our home, we'll only see the effect. But there is also some other way it could be present, like if we have internet at home, for example, fixed internet, well, we have some networking device, some kind of modem and so on. And this device, well, that could be also managed by OpenFlow, because there are many different directions how the evolution of this box, of the modem that you have in your home, how it can evolve. One of the options is also that it will be dumb, but speaking with OpenFlow and asking some controller in the operator's network, and that indeed would help to build new, flexible, and fast deployable services from the operator. So yeah, that's also a way.
I'd like to come back to my question here about change in roles. Assume you defined a role for routing some kind of packet, and switch and the switch remembered it, and from some point you now want change this role to something else. Does the switch forgets about the role at some point, or is the new role pushed to the switch?
So first quick answer, yes, the switch can forget about the rule, and there are two kinds of timers, timeouts, soft timeout, and you can give all those two timeouts within the rule. So you can say to the switch, this is the rule, and it's valid with those two timeouts. Soft timeout is the amount of time when there is no such traffic. If there was no match of this rule for several seconds or whatever you configure, then this rule gets deleted. And the hard timeout is just delete this rule after this time, never mind if there was some traffic or no. And perhaps there is also a message for implicit removal of the rule, but I'm not sure about it. At least I don't see it in my notes about the POX API.
So there is no push notifications?
Push notifications from the...
From controller to network appliance device.
Can you repeat your question?
Yeah, so there is no push notifications because one of the hard problems, as everyone knows, is the cache invalidation. And it seems that here you pull the information from the controller each time. So I guess the question was also kind of if you could invalidate actively the cache state.
Mm-hmm.
So the controller sees that the network state is changed. Can I notify the device that it should not use this rule anymore?
Yeah, for sure you can override the rule. I mean, this is asynchronous communication, so in any moment the controller could send a new rule to the switch. Controller could also ask a switch to completely clear its table, forwarding table, and so that there are some means for this, and for removing some specific rule. And this, well, I don't know. That's a good question.
Okay, thank you for your questions. And the ultimate network specialist, Konrad Gawda. Thank you.